Hello everyone, in this video lecture I will be discussing about nanomaterials and properties of nanomaterials. What do you mean by nanomaterials? The word nano is a Greek word meaning dwarf or something very small. Nanomaterials have physical dimensions of range of 10 to the power minus 9 of a meter. Nanomaterials have size in the range of 1 to 100 nanometers. Materials of nanoscale have unique optical, magnetic, mechanical, electric and thermal properties. Nanomaterials can be naturally occurring or synthetically derived. Some examples of naturally occurring nanomaterials is shown in the below diagram. Volcanic ash, soot from the forest fire, the lizard legs. The lizard feet is covered with nano-size hairs that use intramolecular forces to stick firmly into the surface. The virus size lies between the range of 1 to 100 nanometer. The butterfly wings is made up of fine nanomaterials. Lotus leaf is able to repel the water due to the nanoscale hair-like structure on its self-cleaning ability. So these are some of the important examples of naturally occurring nanomaterials. In the next slide, we will be discussing about synthetically prepared nanomaterials. Examples for some synthetic nanomaterial include fullerene, carbon nanotubes, graphene, dendrimers, and carbon nanorod. So why nanoparticles? Nanoparticles, though they are very small, yet they have a very big impact on our everyday life that makes them exciting and important. Nanomaterial has gained a tremendous amount of transition in last 2 decades because of its application. In the short-term application such as in cosmetics, textiles, automobile sector, aerospace, electronics, food and paints. In longer term applications such as drug delivery where they could be used to deliver drugs to the specific site in the body. How small is a nanomaterial? Generally the nanomaterials are the particles having size between 1 nanometer to 100 nanometer. In the below chart, the size comparison of nanomaterials with the other materials is given. The size of the hydrogen atom lies around 1 angstrom to 1 nanometer. The size of the glucose molecule is 1 nanometer. The size of hemoglobin lies between 10 nanometer to 150 nanometer. The size of the virus lies around 10 nanometer to 100 nanometer. The size of E. coli lies around 150 nanometer. The size of red blood cell lies between 1 micrometer to 10 micrometer. The average size of human hair is around 100 micrometer. The size of the hand is around 10 centimeter. The size of the normal human being is generally above 1 meter. So this is the size comparison chart of nanomaterials with the other objects. Applications of nanomaterials. Nanomaterials have wide range of application in almost all fields. Nanomaterials are now having deep root in every segment of today's world, whether it is textiles, biomedical, healthcare, food, agriculture, industrial, electronics, environment and renewable energy forms. Few applications of nanomaterials are given in the below diagram. Size-dependent properties of nanomaterial. A size-dependent property is a physical property that changes when size of the object changes. In this, I will be discussing various size-dependent properties of nanomaterial. Optical property. Nanomaterial exhibit different colors when compared to bulk material. The discrete electronic state of nanoparticles allow absorption and emission of light of specific wavelength. Nanomaterials have high optical band gap when compared to their bulk counterpart because it follows localized surface plasmon resonance phenomenon. This is a phenomenon because of the interaction of conduction electron of the metal nanoparticle with the incident photon. Because of it, the nanoparticles show different color when compared to their bulk counterpart. Bulk gold is yellow color. You can see in the below diagram the color of the bulk gold is yellow color, whereas the nano gold appears red in color because particles are so small that the electrons are not free to move about as in bulk gold. The restricted movement of the particles make particle behave differently with light. Electrical property. In a case of bulk molecule, there is delocalization of electron. An electron move in any direction. So there is overlapping of orbitals in bulk particle. But in nanoscale, there is a discrete band gap. Metals which are good conductors in bulk become semiconductor and finally insulator when the size decreases to nanoscale. Surface area. Nanoparticles have relatively larger surface area when compared to the same volume of material made up of bigger particles. As the particle size decreases, greater number of atoms are found at the surface when compared to those of inside. This makes nanomaterial more reactive. Consider an example for a gold nanomaterial. In the below diagram, the various sizes of gold nanomaterial is given, the bulk scale and the nanoscale. Consider a cube with each side of 1 meter with a volume of cube 1 meter cube. The surface area of that kind of cube is 6 square meter. Next, the same gold nanomaterial is further divided into small cubes of 1/4 of the meter. The surface area of that gold nanomaterial becomes 24 square meter. Again, the same gold nano cubes is further divided into smaller size of each of side 1 nanometer. Number of cubes becomes 10 to the power 27 and the surface area becomes 6 billion square meter. So we can see in the below diagram the size comparison of gold nanomaterial with the bulk scale and with the nanoscale. So we can conclude that as the size decreases, larger surface area is seen compared to the bulk molecule. As the size decreases, greater number of atoms are found at the surface when compared to those of inside. Because of that, this makes nanomaterial more reactive. Catalytic property. When the size of the particle is reduced to nanometer range, a large fraction of atoms are located at the surface of nanomaterial, which will modify its catalytical property. Properties such as gas absorption and chemical reactivity increases as the particle size decreases. Therefore, nanomaterials are more reactive than bulk scale or larger material. Titanium nanomaterial doped with silver or gold or platinum are found to be good catalysts to absorb the pollutants from the atmosphere, whereas the bulk one is inactive. Lastly, the thermal properties. In nanoscale, there is a large fraction of atoms are present on the surface, and because of that, these atoms can be easily removed when compared to the bulk atoms. Therefore, the total energy needed to overcome the intermolecular forces is less in nanoscale material. The size of the nanomaterial decreases, the melting point also decreases. So when you see the melting point of gold, it decreases from 1200 Kelvin to 800 Kelvin when the particle size decreases from 300 angstrom to 20 angstrom.